Welcome to lesson 2, our second lesson on areas and perimeters. So these problems are a little bit trickier. We're going to read through them carefully. I'm going to explain to you how I would solve them. So question 1, given square ABCD, which is a small square, and then CBEF, that's that bigger one in an angle, right triangle, this right triangle, right here, AGC, it tells us that the area of that right triangle is 10. And they want us to find the area of the polygon, so that means not a regular shape, of the polygon B to E to F to C to D and back. So we're going to find the area of that shape in there. And the way I did it was as follows. If we know that that little yellow triangle has an area of 10, then that means that the other area, since that ABCD was a square, it means that AGB is also 10. If those two are both 10, then this triangle, I'm going to switch to red, then this triangle here must be 20. And if that triangle is 20, then I'm going to draw some dashed lines. If we take the square that has the pink part in it and we split that one into quarters, if 1/4 was 20, then that would be 20, that would be 20, and that would be 20. So that means that BEFCD is going to be 3 times 20 or 60 units squared. So that's how I would do that problem. Question 2. Fred has a fenced-in circular dog pen, so obviously the word circular was important, with an area of 78.5 meters squared. He wants to increase the area to 100. So we're going to increase it to 100, and to the nearest centimeter, find out how much extra fencing will he need. So to the nearest centimeter means we're going to round to 2 decimal places because everything else will be in meters. And they're asking us how much extra fencing will he need. So it's really asking us what the increase in the perimeter, or because this is a circle, it's also the increase in the circumference. I might have spelled that wrong. Okay, what do we know? We know we have a circle, radius r, because we don't know what the radius was, but we know that the area was 78.5 meters squared. So if we're looking at the before, like our starting position before, we know that area equals pi times r squared, but we know that the area is 78.5. Pi is 3.14 times r squared. Divide both sides by 3.14, and we get 25 equals r squared. I'm going to square root both sides. I'm only going to take the positive square root because we're looking at distances. So we know that the radius is 5, and I'm going to use that to find my circumference. And a reminder that circumference is equal to 2 times pi times r, 2 pi r. So that's 2 times 3.14 times 5. So that's 10 times 3.14. So that's 31.4 meters. So before we make it bigger, we have a circumference of 31.4. And then we're going to go through this again, but we're going to do it after, once it's bigger. And once it's bigger, we know that we want the area to be 100. So 100 is going to be 3.14 times my new radius squared. Divide both sides by 3.14 because I want to find out what that new radius is going to be. And I get 31.85 equals my new radius squared. Square root both sides to 2 decimal places. I get 5.64 equals my new radius. So if that's my new radius, I can now use it to find my new circumference. So my new circumference is going to be 2 times 3.14 times 5.64, or my new circumference equals 35.42. And again, it was in meters. So I found my original circumference. I found my new circumference. To answer this question, I have to find the increase in perimeter. So that's going to be my change in circumference. So my last part, I'm going to find the difference between these. So the difference is going to be 35.42 minus 31.4, and that gets me, put a 0 there, 4.02 meters. So my difference is 4.2 meters. So therefore, he will need 4.02 meters more fence. Question 3. In question 3, a square kilometer of land has become contaminated with radioactive waste. Because of the radiation, no one can live within 1 kilometer of any point. So I'm going to back it up. It starts off with a square kilometer of land. I highlighted that green. So I've drawn a square kilometer of land and highlighted it green. Then it says, because of the radiation, no one can live within 1 kilometer of any point within the contaminated area. So it's easy enough from the sides. From the sides, 1 kilometer away is going to mean that I'm going to not be able to do anything in each of those squares that's 1 kilometer away to the sides and to the top and the bottom. But then we got to think about the corners. And in the corners, it said we have to be 1 kilometer away. So if I was going to visualize it, I'm going to start off at 1 kilometer away, and it's like you've got a radius sweeping out that's 1 kilometer long all the way along as it goes around that curve. And it's not letting me draw. Oh, I've just got to let go earlier. It's going to be a half circle. And for each of these corners, it's going to make a half circle that has the radius of 1 kilometer. For all of these corners, a 1 kilometer radius. And it wants us to find, so always looking at what they're asking for, find the number of square kilometers, including the interior, that are uninhabitable. So if we're going to look at the total number of the amount of area that's uninhabitable, we're going to have 5 of the squares plus 4 of the quarter circles. Okay? Each square had an area of 1 kilometer squared, so that's going to be 5 times 1. For each circle, if I have 4 quarters, that's the same as saying 1 full circle. 1 full circle with a radius of 1 kilometer. So that's going to be, the area for 1 full circle is pi times the radius squared, which is pi times 1 squared, which just gives us 5 plus 3.14. So the contaminated area would, the uninhabitable area, would be 8.14 kilometers squared. And we'd end with a therefore statement. So therefore, the uninhabitable area is 8.14 kilometers squared. Question 4. If ABCD is a unit square, so unit square means each side has a length of 1, find the area of the unshaded region. So to find the area of the unshaded region, area unshade is going to be equal to our big square, and then we're going to subtract 2 times that triangle shape, because we have 2 of those triangles in there. So obviously we're going to have to figure out what the height of the area of each of those triangles. So if we're finding the area of our triangles, we know that the area of a triangle is base times height divided by 2. So let's look a little more carefully at our square and see if we can figure out anything about it. One of the first things I notice is that this length here is 2x, which means that length is 2x, so it means that one is 2x. Also, we've got that double line, so it means that that's 2x and that's 2x, and it means that one's 2x also. If we look at x here, I've got x, so that means this is also x in purple, and on this far side, that's x. The one line shows that that is also x, also purple x, also purple x. So it means we've got, for each triangle, it's got a base of x and a height of 2x. So a base of x and a height of 2x. So x times 2x divided by 2. So that's up top going to give me 2. And then x times x is x squared divided by 2. I'm going to cancel my 2's, divide them. So I'll get the area of one triangle is x squared. Okay. But we need to find the area of the unshaded region, and we need the area of the big square. So we also need the area of the big square. Well, we know it's 1 times 1, so we could just say it's 1 times 1, which is 1 unit squared. But we also now have enough information. We know that the height and the width of this square is actually 3x. And we can do that because x plus 2x would give me 3x, and x plus 2x here would give me 3x. So overall, I could also write that it's 3x times 3x, which is 9x squared. This is important because we'll use that later to turn it into a units thing. But now we can go back to our big thing for the area of the unshaded. So our big square is equal to 9x squared. Our triangles, we have 2 of them, and each one is x squared. So I've got 9x squared minus 2x squared. So the area of the unshaded thing is 7x squared. Now you could leave it at that. But we know that 9x squared equals 1 unit squared. So that means 7x squared. We don't know how much that's going to be, but we're going to be able to use it by fractions. So I can cross multiply, I can do whatever we want. But we're going to have 9x squared over 7x squared equals 1 over question mark. However you want to solve for question mark, I would just flip them upside down, cancel the x's. We're going to get that the area unshaded, which was the question mark, is going to equal 7/9 of a unit squared. Question 5. Yes, I know I've already drawn a lot because it would take me too long to do it while I'm talking. A circular piece of metal of maximum size is cut out of a square piece, and then, so cut out of a square piece. The square piece I did as the first blue square, and then I did a red circle inside it. And then it said a square piece of maximum size is cut out of that circular piece. So that's that green square inside. So we had a square, we cut out a circle, and then we cut a square out of that circle. And they want to know what percent of the original piece was wasted. So that means what's going to be left over. So that's going to be what I colored yellow. whenever there's a question like what percent of the original piece, I always try to make my original area 100. So in this case, with the blue square, if we choose a side length of 10, that means that my original area of that blue square would be 100. So if we can find the area of the green square, it's already a percent, which makes our life much easier. And the first thing we're going to do is find the radius of the red circle. So if we know that all the way across is 10, I hope you can see that the radius of the circle would be 5 because it's halfway across. So the radius of the circle is going to be 5. So that means from the center to the edge, I'm going to draw it on top, that radius would be 5. But also, because I'm going to get rid of that now, it also means that if I start at the center and go to the edge of my circle like here, that radius is going to be 5. Radius is 5. And if we go here as well, also a radius of 5, I now have my square. I could break it into 4 of these triangles. So I could break it into, so we want to find area of this triangle. Oh, I didn't draw that very well. Of this triangle that happens to be a right angle, where I've got 5 and 5. I don't need to write that as the radius. If we can find the area of that, then I can times it by 4 and I'll get the area of the green square. So for this, area is base times height divided by 2. So that's 5 times 5 divided by 2. So that's 25 divided by 2. That's 12.5. So the area of the green square is going to be 4 times the area of the triangle. So that's going to be 4 times 12.5. So that's going to be 50. And because we didn't have units, whatever. So we know that our original area was 100. Our area of our green square is 50. And they want to know how much was wasted. So the area wasted is going to be what we started with, 100. Take away how much got used by the green square, which was 50. So how much is wasted is also going to be 50. And I know they were in units, but we made them equal to percent. So the amount, what percent of the original piece was wasted. So therefore, there is 50% of the original wasted. Question 6. A rectangular field is half as wide as it is long and is completely enclosed by K yards of fencing. Whenever they talk about fencing, that's going to be talking about perimeter. And they want us to express the area of the field, but in terms of K. So I'm going to start off with that perimeter stuff. So if we were to look at our rectangle, so I've drawn a picture, I've labeled it width, and I know that the length, it's half as wide as it is long, so that means it's twice as long as it is wide. So if the width is W, the length is 2W. So this perimeter would be W plus, I'm going to pretend I'm walking around the outside of the shape, W plus 2W plus another W plus another 2W. So I'm going to get that my perimeter equals 6W. But we also know that the perimeter equals K, which is super weird, but we're going to write it down. So it equals K. They asked us, though, to find the area. So the area of a rectangle is just length times width, or in this case, 2W times W. So the 2 stays out, and then W times W gives me W squared. So I get the area equals 2W squared. But they want the area in terms of K. So what we're going to do is we're going to take our K equals 6W, and we're going to isolate W, and then we're going to sub it into there. So isolate W. I want to get W by itself. It's being times by 6. I divide both sides by 6. So I get K over 6 equals W. That's what I'm going to sub in. So I'm going to get 2 times K over 6. And that whole thing is squared. Now I have to remember my exponent law. I distribute it onto the top and the bottom. So the top is K squared. The bottom is going to be 6 squared, which is 36. We've got some canceling we got to do because that's really a 2 over 1. So 2 goes into 2 ones, goes into 36 18 times. And we get that the area equals K squared over 18. For the next, and I believe the last one. Yeah, it's the last one. Okay, we have a rhombus. A rhombus is a parallelogram with all sides equal. It's like you had a square and you pushed it over, but its bottom didn't move. A rhombus is formed by 2 radii. Radii is the fancy word for the plural of radius. Instead of saying radiuses, we say radii. So a rhombus is formed by 2 radii and 2 chords. Okay, another word to define. A chord goes from the edge of a circle to another edge of a circle, not through a center. Okay, so a rhombus, 4 sides. 2 of them are radii, 2 of them are chords of a circle. They tell us that the radius is 16. So that's going to be useful. R equals 16. So that's going to be 16. That's going to be 16. What is the area of the rhombus? So what we're aiming for in this one is the area of a rhombus. But we don't have a good, it's like a parallelogram, but we don't have the height. So there's a trick in this one, and the trick is to use that radius of 16. So if radius goes from the middle to the edge of any circle. So that also, that I drew there, that radius is also going to be 16. And now it looks like we have 2 triangles. Or we don't even need to have ever the triangles. If we could then figure out the height of that triangle, we could figure out the area of the rhombus, because the area of a rhombus is going to be like the area of a parallelogram. So it's going to be like base times height. We know the base is going to be 16, but we don't know what the height is, so we're going to figure that out. Okay, we're going to figure it out by finding what the height is in the triangle that I just made orange. So if we were to draw that out again, we have a triangle. We have a triangle that has 16, 16. We don't know what that H is. We know that 16 grows across the bottom. So that means that this part here, that's going to be 8. So I could figure out what H is by using Pythagorean. So H squared plus 8 squared equals 16 squared. So H squared is going to equal 256. I'm going to take that 8 squared and bring it over to this side and subtract it. So minus 64. So H squared equals 192. I would square root both sides. When we square root 192, we get either that it equals decimal form, 13.86, or the square root, which would be 8 root 3. That would be more precise. So we've solved for the height. We've solved for this height here. So now we can get our area of our rhombus. So our area of our rhombus is either going to be 13.86 times 16, which is 221.7 centimeters squared, or it'll be 8 root 3 times 16, which is 8 times 16 is 128 root 3 centimeters squared. And so both of those work as our answers, and I'm double checking. Yeah, 8. We are done. Either with decimal or with square root would be fine. Thanks for watching.